Assalamualaikum warahmatullahi wabarakatuh and hello. My name is Anas Putra bin Azahari and my number matric is A22A0394. Today, we want to present about the business statistic set B. These are the members of my group of 6 people and I am the leader in this group.
Hi, my name is Dveshni Haridas. My metric number is A22A0273. Today I want to present about the data description in Statistik. A data set is a collection of information that is usually presented as a table. Each column corresponds to be a different variables. Each entry in a member's data collection represents a query. It lists the random integer values for each variables such as the height and weight of an object or value and refer to each value as a data sheet. In statistics, the data set is often created from a sample statistic population based on a real observation, with each row representing a portion of the population that was observed. In this assignment, we are provided a data set of a price of fish couch in various locations, comprising 160 observations. Based on the lowest magic number of our group members, we choose 141 out of 160 random cases. Our data set consists of the secondary data. Secondary data is information that was not collected and used for the study's intent aim but was instead used for another purpose. To put it another way, repurposing existing data. Secondary data as opposed to primary data can save time that could otherwise be spent gathering information. The main flaw in this data is that this isn't updated. It will become obsolete. Thank you. Next, I will hand this slide over the next presenter.
2.0 Sampling data and recording categories data. It can be seen that this is 16 data sampling that we select for the 116 data observation. Next, that is record categories data. It can be seen that we have recorded categories for the fish species and recorded categories for where the fish were catched.
For 3.0 numerical descriptive measure, 3.1 measure of central tendency. A measure of tendency is a value that represents the center of discipline. There are three most commonly used measures of tendency for ungrouped and grouped data are: first is mean, second is median, and third is mode. For the central tendency for a price, mean is 154.483, for a median 105.2833, and the for mode is 77.4102. Central tendency for a weight, mean is 167.2, for the median is 116.77, and for the mode is 84.64. For the 3.2 measure of position, a measure of position determines the position of the single value in the relation to other value in the sample or the population data set. There are several measurements for the position which include quartiles, delis, and percentiles. Measure of position for a price is first quartile is 53.2417, a third quartile is 157.325. For the range is 104.0833. Measure of position for a weight is a first quartile is 58.1364, a third quartile is 225.25, and for the range is 167.1136. 3.3 Measure of variation. Measure of variation, also known as a measure of dispersion, are statistically values used to describe the spread of variability of data points in the dataset. They provide information about how spread out or clutters and the data is around. The measure of central tendency. Common measure of variation include the range, variance, and standard deviation. Measure of variation for a price is the range is 993.96, variance is 739.96, and standard for deviation is 95.6202. And the measure of variation for a weight, the range is 1650, variance for the variance 9699.32, and the standard deviation is 98.4852.
Assalamualaikum and selamat sejahtera. My name is Siti Nurain binti Rusli and my matrix number is A22S0563. So, 4.0 graphical representation. As we can see in this slide, there is OGIF graph that represent price. As we can identify from the OGIF, the graph begins at 2.1, where the cumulative frequency is 0, and end at 746.1 when the cumulative frequency is 60. So we can conclude that a frequency of 36 and a price range of 1.7 until 125.6 indicate that there is more fish in this price range. Next slide, the histogram that represent weight. The graph begins with the midpoint is 64 at the x-axis where the frequency is 33. And in the last class with the midpoint at 702 where its frequency is 1. Since the frequency is higher than the other classes, we can infer that the fish have the highest weight between 0 to 128. That's all for 4.0. I will pass this presentation to the next presenter. Thank you.
5.0 Statistical Analysis using SPSS. SPSS stands for Statistical Package for the Social Sciences. SPSS provides data analysis for descriptive statistics, numerical outcome prediction, and group identification. This software also provides data transformation, charting, and direct marketing functions to manage data smoothly. There have two different numerical descriptive measures, which is calculated using by SPSS and manually. 5.1.1 Draw graph by using SPSS software. From the first graph, we can see that the x-axis represents the upper boundaries and the y-axis represents the cumulative frequency for the price. From the second graph, the x-axis uses the midpoint and the y-axis uses the frequency. 5.2 Hypothesis Testing. 5.2.1 Using the t-test. Step 1. State null hypothesis and alternate hypothesis. Step 2. State the level of signification A equals to 0.05. Step 3. Output SPSS. Step 4. Decision rule. Critical region, which is 2.055. Step 5. Decision reject. Therefore, we can conclude that the mean is equal to the price and the weight group. 5.2.2 Test of normality. We are using test of normality to determine if a data set is well modeled by a normal distribution and to compute how likely it is for a random variable underlying the data set to be normally distributed. Therefore, in this part, we want to test whether the price and the weight fish. 5.2.3 ANOVA Step 1 Hypothesis. At least one of the mean is different from the others. Step 2, signification level. A equals to 0.05. Step 3, SPSS output. Step 4, decision, which is the critical region equals to 2.38607. Step 5, decision, which is conducted that there is a signification difference among the treatment means.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Idah bin Sanusi. My entry matrix is AA2A0460 45.3 correlation analysis. Correlation analysis in research is a statistical method used to measure the strength of the linear relationship between two variables and compute their acceleration. Simple put, correlation analysis calculate the level of change in a one variable due to the change in the order. Hypothesis 1. Hypothesis H0. There is no correlation between price and weight. H1. There is a correlation between price and weight. Step 2. Significant level, which means is 0.05. For the step 3, SPSS output. For the step 4, decision rules. Reject 0 if p-value small and same. P-value, which means 0.001. For the step 5, decision. Reject 0. Since p-value small and same in bracket 0.001, small and same 0.05. Thus, we can conclude that there is no correlation between price and weight. This table shows its correlation is significant at the 0.01 level 2 tail. For the 5.4 confidence interval. Confidence interval is referring to evaluate the interval of statistic contain a population parameter. By using the SPSS, we collect the result of the 95% confidence interval for years lower boundary in the bracket 0.928, and the upper boundary is 1.0001. The standard error for this dependent is 0.018. Besides that, it can be said that 95% confident that the Persian parameter is between 0.928 and 1.001. This table shows is the coefficient.
Assalamualaikum. My name is Ifarina Rahim and my matrix card ID number is A2280292. Next, we go through to the prediction modeling. In this result, the R value between price and weight is 0.990, which is length 1 and weight are 0.960, which is both are more than 0.07. Thus, weight is associated with both price and length 1. The R value between the price and length 1 is 0.949, which is less than 0.98. Perhaps there is no problem with the multicollinearity. Next, we go through to the next subtopic, which is test of normality under topic prediction modeling. Based on the table above, we can identify the Shapiro-Wilk test of normality on the residual gives a value of 0.114, which is more than 0.05. Thus, the assumption of normality of the residual terms is met. Next, we go through to the next slide, which is the model summary. From this table, we can know that the R squared is equal to 0.979, which means 9.79% of the variation in this price can be explained by length 1 and weight. Then we go through to the next slide, which is ANOVA. From this table, we can know that the p-value from the ANOVA table is 0.001, which is less than 0.05. Therefore, at least one of the two variables, which are price group and length 1 group, can be used to model the weight of the fish. Then we go through to the next slide, which is coefficients. Before we want to do the calculations, we must know the equation of coefficients and the equation of weight, which is the equation of coefficient is equal to y equal to b0 plus b1 times up by x1 plus b2 times up by x2. Then the equation of weight is equal to weight group plus by length 1 group. Based on the table above, we can identify the weight group is equal to 1.960 plus by 0.977, then we plus it with negative 0.238. Then we can get the answer for the equation of weight. Thus, for every unit in weight, the price of fish will increase by 0.977 while the weight group remains unchanged. Similarly, for every unit increase in length 1, the price of fish will drop to negative 0.0238 and the length 1 of the purchaser fish remains unchanged.
Next, we still continue under subtopic coefficient. Based on the standardized beta coefficient, the effect is a 1.003, which is about the 10 time 1.003 slash negative 0.14, approximately 10, higher than the effect of leg 1, negative 0.014 in magnitude. The p-value for the week is a 0.001, which is a less than 0.05. Thus, week is a significant predator of the price. The p-value for the leg is a more than 0.001 rather than 0.05. Hence, leg is not a significant predator. The 95% confidence interval for the week is a 0.846, 1.109, where the value of the 0 does not fall within an interval, again indicating week is a significant predator, whereas the 95% confidence interval for the leg 1 is a negative 2.582, 2.10c. They are interval of the 0 fall within the interval, again indicating the weight group is a significant predator. A statistical analysis conducted on a dataset containing information on species, sale price, weight, leg, height, and weight. The analysis focused on two sub-simple, price and weight. Variance statistical calculation we performed included class internal determination, frequency, cumulative frequency, midpoint, upper bound, and lower bound calculation for graphic representation. The dataset was described using numerical descriptive measure such as measure of central tendency, position, and variation. Both manual calculation and the SPSS system were used to compare the result. Different were found between the manual calculated value and the SPSS output for mean, median, mode, standing deviation, variance, first quarters, and third quarters. However, that were not different in a range, maximum, and minimum value. Hypothesis testing was conducted using the independent sample t-test and ANOVA table. The analysis led to the conclusion that there is not significant difference between the mean, weight, and price group. The ANOVA test showed a significant difference between the terms. Correlation analysis was performed using Scarlet plot and correlation table. The correlation between price and weight was found to be significant. Different interval was also calculated, and the 95% confidence interval for weight was determined. The confused table revealed the impact of weight and leg on fish price. For each unit increase in the weight and price of the fish increased by 0.977, but keeping the weight unchanged. For the unit increase in leg, the price and the fish decreased by negative 0.0238, with leg in the remaining unchanged. Confidence interval was provided for the weight and leg, indicating the significant as predator.